All right, welcome to Serverless Office Hours. I am Eric Johnson, also known as EDJ Geek. It is good to be back. I have been out and around, and it's good to be back live streaming. And look who is with me. I have Dhiraj. Ready? Here I
Yes.
go. And you're going to be honest if I get it right or wrong, okay?
Yep.
It's Dhiraj Smith.
That's perfect.
Did I get it right?
Actually.
Okay,
Yep.
all right. So it's
I cannot
Dhiraj.
be more American than this.
It's Dhiraj Mahapatro.
Yes.
Now you say it.
It's Dhiraj Mahapatro.
Yes, so not correct, but you're very nice. I appreciate that. And it's Sam Dengler.
That's right. You got it first try.
Yes, and I am Eric Johnson. Now, I'm super excited to have you all on here. We're going to be talking about something really cool. But real quick, tell us a little bit about it. I'm going to start with Dhiraj. Can you tell us a little bit about who you are, what you do at AWS, and why are you even on this show?
Yeah, that's the best question. So first of all, my name is Dhiraj Mahapatro, and I'm the Senior Serverless Specialist SA. And I've been with AWS for 2 years and 6 months. Now, I specifically work with global financial services customers. So it's easy to see what enterprise level work they do and how serverless can help them. Now, that being said, we focus on our serverless services and messaging services, but we are not limited to just when we talk to customers, we're not limited to saying that, hey, you should use Lambda or you should use SNS. Right. It's about understanding and working backwards and see what fits best for them. So that is what I do in my day-to-day work with financial services customers.
All right, Sam, tell us who you are.
So I'm Sam Dengler. I'm a principal solutions architect, and I work in the serverless space as well. And more specifically, I focus on event-driven architectures, and I work really closely with the step functions and event bridge teams. And I talk to customers all over the world about building event-driven architectures using those services, as well as Lambda and API Gateway, SNS, SQS, the other sort of suite of serverless services too.
Nice. Now, I'm going to tell you, a long time ago, I made the statement, if you're the smartest person in the room, you need to change rooms. Today, I'm changing rooms. I'm the dummy in the room here, folks. These are some really sharp folks that are here to answer questions. So I really encourage you to ask the questions. Let's stump them. You know what I mean? I would love for Sam to go, I don't know. I don't think we can do that because Dhiraj will be like, I know. You know, no. but it's easy to get Eric to go, I have no clue. So, but let's, so if you have your questions, all honesty, all kidding aside, if you have your questions, that's what this is about. We're going to be presenting, first of all, let me just say real quick, here's what we're talking about today. We're talking about local mocking for step functions. And so Sam, let's start with you. In a nutshell, what's the elevator pitch? What is that?
So customers use step functions to build workflows in order to integrate with AWS services and orchestrate AWS services to solve a problem. And because step functions' primary job is to manage the control flow of those integrations with services, there's lots of API calls and integrations that happen with those services. When customers are building their workflows, they want to test the flow of the workflows. There's lots of things you can do with step functions about conditional logic and retry logic. And a lot of developers want to test those behaviors without actually integrating with AWS services during sort of a local phase so they can get really fast, iterative feedback loops and be more productive. And Dhiraj and I, as you did too, we were all at reInvent this past year. And this was the number one question I had from customers and during chalk talks and breakout sessions was, how can we achieve the same thing that we're used to doing with say like a Lambda function and the SAM CLI and a local invocation? How can we do something similar with step functions? And so this local mocking support for step functions allow you to describe the successful or error responses that you would like to test from the AWS service integrations that you have in your workflow and to exercise those locally before you deploy into an AWS account and do more full integration tests with the real services.
This is super huge, and I'm gonna Ben Kehoe gave me a dirty look on Twitter. I'm okay. I can take it. He wears suspenders. There it is. But so Ben Kehoe, when I said we're going to be talking about local mocking, now for the last, 7 or 8 months, you choose, I have been talking about, developing, debugging in the cloud with SAM Accelerate, right? So our mantra has been get to the cloud as fast as you can. But this almost comes across as, well, wait a minute, But so I'll give my opinion in a minute, but what do you say to something like that? Well, hey, you've been saying develop in the cloud. Why the local invocation? Why the local mocking?
Yeah, so it's not an either or choice. Both are appropriate. In addition to other types of tests you want to use, in your journey from a local development into a production environment. So a lot of times when we're thinking about continuous delivery patterns and integration patterns, we want to exercise the cheapest tests we can, the soonest. So if there's something like an easy mistake, like it's a syntax error, for example, we don't want to wait for a full build and deployment cycle into an integration environment just to discover something that we could have discovered earlier in the process. And ultimately, when we look at a full integration pipeline, we're adding the tests. The tests get longer, but we get more value for them as they go along. So why not take an opportunity to test the easy things up front, and so you get that fast feedback loop before you quickly get into the cloud and get the real experience, because there's no substitute for actually testing the behaviors of these integrations between the services. Is something you really can't mock locally. It's just more of the functional aspects of it.
Yeah, I would agree wholeheartedly. Dhiraj, before I jump in with my opinion, which I think highly of my opinion, but what do you think? Anything you would add or take away?
Definitely.
You guys want to go at it?
What I like best about this approach is, as a developer, you can synthesize your service integration failures. So if you're writing local step functions, local mock config, and you want to test how should my state machine behave if Lambda service is sending back an SDK exception or sending back a server exception, how should my state machine behave if I cannot put events in event bridge? You can synthesize all of those behaviors inside your mock config, and you can readily test them with retries, with catch, and then you can go forward with how it should behave and how close you can build that to your business requirement. So that empowers you to build that using mock config.
Yeah, I agree. I think the other thing I would point out is it helps you before you're even deciding on your infrastructure, right? Here I'm looking. I've decided. I mean, and Rob, I know you're out there. Rob Sutter's already made a comment on my name. I'll just throw that up there. Rob and I got into this battle many years ago. Rob used to be one of the DAs here. He's now with Fauna Serverless Database, and he was. You should always use step functions. Now this is pre synchronous execution, and pre synchronous execution. And I was like, I think that's a little aggressive, Rob. And I think I was right at that time. But I'm telling you now, I feel like for most workloads, step functions is kind of a good starting point, right? To start figuring out how am I going to lay this out? And this mocking ability gives me the ability to say, before I ever start spinning up executions, quick sanity check locally. And I love that idea. And that would be my answer as well. You guys have obviously covered it entirely, but I like to repeat things. I would tell folks that a local sanity check, there's never anything wrong with that. SAM local mocking with step functions, a local sanity check. Get to the cloud as soon as you can. Security, architecture, things like that, but a local sanity check, never anything wrong with that. And I'm really glad that we've offered this, ability to do that. Now, Dhiraj, before we jump in, I know you have some things you're going to show. I have a statement here. I want to see what you all think about it. Steve, excuse me, I'm sorry, Steve Thomas is probably just Thomas. I like to I'm really cultural. I think that simply put, we want to unit test the step functions themselves, mocking their dependencies such as other AWS services plus Lambdas. What do y'all think? Agree, disagree?
Yes.
Yeah.
Okay.
Yeah, I agree
You're
with
both like, okay, great. You have great radio faces. I appreciate it. So okay. Real quick, I'm going to see if we have any other questions. And then, Dhiraj, are you ready to kind of show your stuff?
Yep, we can.
Alrighty.
Sure.
Now, what are you going to show us? What are you going to be showing us?
So we'll walk through the blog, what Sam and I wrote, and talk about the use case why we chose that, and then dive deeper to the sample application where we can walk through the mock config file and see what are the test cases that we are trying to address in that sample application, and then switch to see how we can address application owners or teams which are using existing toolings like existing frameworks like Java and their unit test case, how they can leverage that to run this mock config tests and do some assertion on top of the history. So we can walk through in that pattern and see how it looks like.
Man, those are big words. We'll see what happens. So, all right. Okay. So I have just, if you're following along, I've just posted the blog link. If you want to link to the blog that Sam and Dhiraj wrote, it's a phenomenal blog. And I'm going to share your screen if you're ready, Dhiraj.
Yep. Go ahead.
All right. Here we go.
Sam.
Yeah, thanks.
There we go.
So, so our blog, Dhiraj, maybe you can scroll a little bit down.
Yeah, let's
to the
let's blow that up a little bit.
to the diagram. So, so Dhiraj and I actually thought quite a bit about the use case that we wanted to demonstrate through these capabilities around. And so here you see a diagram of workflow, and this is a screenshot actually taken from the Workflow Studio. So if you haven't used step functions before, you can go inside the AWS console and you can actually design these workflows using a really great, nice visual editor that you can drag and drop these things and sort of very quickly build the sort of scaffold out your workflow. And so we wanted to demonstrate a couple of features of step functions and how it could work with the mocking capability. So some of those are the different service integrations we have. So we have integrations with Lambda functions, but we're also showing a feature of step functions called AWS SDK integration. So this is the ability for step functions to call over 9,000 plus AWS SD calls directly without having to use other compute as a proxy mechanism.
Crazy. Sorry.
Like you were talking about, that's okay. You're talking about before, Eric, like it really changes the game and you're thinking about like, well, I was writing code before, but really our goal is to build things quickly and to get value and feedback on the things that we're building. So I encourage everyone to sort of look at the code they're writing and see how much of that code is for transportation versus transformation. We often talked about that with Lambda, and where might there be a good fit for the step function service to help you make those AWS service SDK calls directly, where you can describe what you want to do, but not actually have to code for it. And oftentimes we hear from our customers, in sort of this space that code's reliability, every line of code is something that we have to test and maintain over time. So where there's a good fit, and it's not always a good fit, but where there's a good fit, you can look to integrate with step functions and let it take that sort of burden off your plate. So that's why we have the comprehend integration there.
Yeah, it's interesting to me. I told you that I would make this longer because I'd like to interrupt. So here we go. It's interesting to me how much with just, I say simple, I didn't do all the back. It was just simple. It took us like 5 minutes to make that feature, right? There's a lot of work. I mean, it's very, very, a lot of complexity going in. But how much code are we enabling the developers to pull out of their applications by simply doing direct configuration with the ABI calls or the SDK support? And it's just to reiterate how mind-blowing it is that you can quickly code for or you could configure for a lot of things where you may have had multiple Lambda functions and they're gone, or lots of code in your Lambda functions and they're gone because we just configured it. And it's and I love the configuration approach because Eric Johnson, I say this every show and I'll say it again. The most brittle part of any application is where Eric Johnson coded. That's just the truth, right? So but the problem a lot of times with code, it works, but not necessarily the way you were expecting. But with configuration, it's kind of Boolean a lot of times. It is or isn't. Not all the time, but it kind of works or doesn't. So you get a little more security there. So that's all I got. I'm just really cool with that.
Yeah, and to kind of clarify a couple of things, I've talked to customers that see this really cool visual editor and they mistakenly think that it is a no-code experience. This is a low-code experience, right?
That's right.
This doesn't, a lot of using AWS services directly is thinking about like building distributed systems and the behaviors of these systems as they scale and have failure scenarios. And using something like the Workflow Studio or step functions generally doesn't abdicate you from that responsibility of thinking like an engineer about the full solution. So don't make the mistake of thinking because it's not code that you wrote and it's in step functions that it's any less complex or a full, a realistic solution. We have customers that are running business critical workloads at high scale using this technology. The other thing I wanted to point out with this pattern, and I'll describe the use case here briefly, but what you'll see at the bottom of this pattern, so we're demonstrating conditional logic, error handling, and at the bottom, you'll notice that the sort of the terminating integrations for all of these different paths to the workflow are events. So more and more as we talk to customers, we talk about these concepts of orchestration and choreography. Where do we want tightly coupled control over flow and error handling and retry? And where do we want very loosely coupled coordination between systems? And so it becomes a very common pattern where we'll have events or APIs execute or initiate a workflow execution, but the result of that workflow execution might be an event that's published that something has happened, and makes it very easy for other systems and parties to subscribe to those events and process and react to them and with their own workflows or their own code. So we kind of wanted to demonstrate that pattern as well, which is you can have tightly coupled orchestration for coordination that results in events that are published for very loosely coupled choreography for coordination with other subscribers. And so specifically this use case, the idea is based on some work that Dhiraj has been doing in the GFS space. And this shows how we might have a sales lead, for example, that's generated in a customer management system, something like Salesforce, for example.
I'm going to interrupt real quick. Dhiraj,
Sure.
Can you blow that up just a little more? We might have to scale a little bit, but yeah, it's I think it's hard to see. I'm about to ban code with Sean. He's throwing out Kubernetes jokes, and so I'm gonna have to throw him down. So thank you. Yeah.
Sure. So in this example, the idea is like, let's say we get a new lead, like someone has a customer conversation or organization, and it might be someone that is interested in the applications that you're building for your customers. And so that triggers, they enter this data triggers a business event. And this causes us first to verify the identity of that person and their address, for example. Let's do some fraud detection or some validity of that contact because we want to make contact with them potentially. And the next is to look at the comments that that resulted in this customer conversation and use an AWS service. I think of these as superpowers, right? So we have a service called Comprehend where you can send it text and it can come back with a sentiment, and a positive or negative sentiment, and give you an idea of the confidence value in that sentiment. And then we can use that to decide whether this is a contact that we want to store in a database and produce an event that someone else can react to go follow up with that contact. But we're also making a very robust workflow. So there are cases in which we might have bad data, or the identity of a person may not be valid, or their address may not be valid. So we have paths that handle that when we want to handle invalid data for notification. And we might have cases where we have negative sentiment. So maybe we may not want to store that contact for follow-up in a database, but maybe someone wants to be notified of customers that have a negative sentiment about their conversation for a totally different purpose. So we're covering all of those different paths that can happen through the workflow, but ultimately they're resulting in events that are published that others can react to in a very decoupled way.
So what you're doing here is what in a Lambda would be a switch or an if-then or an error handling kind of thing. Rather than writing lines and lines and lines and lines of code to handle that, you're going different routes and step functions based on that.
That's right. And another important aspect of step functions is in these integrations. So when you call the detect sentiment API or the Lambda API, there's the possibility that we might have an exception even from that service, a transient exception when we're trying to call it. Maybe your Lambda functions are returning custom errors based on business logic. And so step functions gives you the primitives to be able to describe error handling behavior and retry behavior, and then you sort of turn over the responsibility for executing that behavior to step functions, and it does it on your behalf. So if you were going to code for this, you would either write conditional logic inside of your code, or you would configure the AWS SDK library that you're using in your programming language to have the same types of retries and exponential backoff behaviors that you can just describe in workflows. It's more of a first-class consideration inside of the workflow domain-specific language than it's something that you would have to sort of think to code for inside of your application code.
Okay, I have a question. If you're at a breaking point here, we have a question that's come in, and this, I think this is a good to explain. So how is data transferred from one block to another in step functions? So if you're new to step functions, and we're asking specific in case of a Lambda. Dhiraj, you wanna take this one?
Yeah, sure. So step functions are built with states. Until the universal service integration or the SDK integration, we had lambdas to do our work inside a state. So the state machine that you have defined as a JSON or a YAML file, or it's called ASL, that specifically shows at what point of time which state should be active. And if you are working on that state, that DSL for whatever the state machine is expecting also expects you to give the information about what should be the next step that has to be executed in normal scenario, in a happy path scenario, or in case of an error, how should I go to the next step. So you define how the next steps should be, and step function just gathers your output from that particular state and provides it to the next state, and the next state can be another lambda function where you can start working on that. Now in the process of providing the output, there are other primitives where you can filter, you can map, or you can reduce your data and then provide to the next state. So all of them are possible by using path parameters, which is taken care in details in one of our user guide docs. But in summary, there are some primitives where you can apply our formatting, or you can transform data when one state output data is passed on to the next state. So that way you can transfer the data, and there is a limit of how much you can transfer from one state to the other. There's a limit on how much data that can come into the state machine and how much data that can transfer in between states.
Is that 256?
Yes, 256 for the data that comes in.
I'm not trying to brag. That's right out of the air. Just pulled that out. So we do have patterns, though, and that's great. And I don't want to chase this rabbit too long, but we have patterns where if you are going to output, let's say your Lambda kicks out some data, and you know it's going to be larger than 256. You can drop it in a bucket and point to there's some patterns where you drop that in an S3 bucket, and what you pass back to the state is a key or a bucket and key, right?
Yep.
And then the next system could grab that as needed.
Yes.
So, yeah. I think we have one other question, and then I want to get back to what you're explaining, but I do want to make sure we answer some of these questions. We have this question. Actually, let's keep on this one. We'll go back here. It's like, there's one parameter payload. What's the main purpose of it?
Okay, so if you're talking in the realm of Lambda as a state, so Lambda expects few items to execute properly. One is the name of the function that you want to execute as part of the state, and what payload that should be provided to the Lambda. So the parameter payload is actually doing that. You're just mentioning that this is the payload that I have to pass into the Lambda, and that payload can be a composition of whatever the previous state has provided as an output.
Okay, great. All right, we have a question from Alper Codes, but we're going to come back to it. I'm not ignoring you, Alper Codes, but I want to give Dhiraj a little time to kind of get into what we're talking about here, and then we'll come back. We'll answer more questions.
Dhiraj, maybe we can look at if you'd like, the
Yep.
GitHub repository. So the blog that we go through, and we can talk about this example here. It covers one potential use case, so to give people a sense of kind of what the mechanics are and how this works, but. The GitHub repository that's linked from the blog has lots more examples for testing both success and failure in each of these different states in the workflow.
Yep.
And I'm posting that link right now everywhere. Alper Codes, I know you will not be ignored. I would never do that unless, of course, I do. It's contextual. So, yeah.
So yeah, definitely. This sample application, which is mentioned or referred in the blog, has more than this particular retry scenario. We like the retry scenario because we like this diagram, and we love to show this how retries would work and how you can test it. But overall, you can test the happy path starting with the simple test case, and then you can do your permutation and combination, which path should the state machine traverse, so that you can test all of the scenarios where your state machine can get exited. So in the sample application, you will see how the input should look like, and the anatomy of how the mock config file should look like, and it defines properly, like you follow the convention of providing state machines as the top level attribute in the JSON file, and the next would be the name of the state machine that you want to test, and then comes what are the test cases under that state machine that you're trying to test, and then you have the number of tests that you are running. The critical thing to do here is your test case should encompass or should cover the mocking feature of each of the state that the state machine would be traversing. So in this case, we have check identity, check address, detect sentiment, and I'm mocking all of those attributes. And this is my happy path test.
Hey, Dhiraj, I hate to be a broken record. That's really
Uh,
small. Can you blow that up? Make it. Yeah.
yes,
There you
definitely.
go. There you go. That's much better. Thank you.
Mhm.
I'm old, Dhiraj, and I can't see things. So
No,
you know.
we both are wearing glasses though.
Yeah, you go with that. We're the same age. You go with that. I'll go with that.
Yeah. So
Sam and all his hair. All right, go ahead. Sorry.
no problem. So in happy path scenario, we mock each of those areas where you expect. So in this example, the happy path is the input data comes in, your check identity, check address passes, you see a detect sentiment and you see a positive sentiment, and you add that as a follow up, and then finally you put an event saying that customer added to the follow up. So this happy path is mocked here, saying anytime a check identity state is needs to be executed, I want to send back a mocked response which is defined by this attribute. Same with check address. Anytime a check address state is getting executed, you don't have to go and call the actual service or actual lambda. Just pick up the response that is provided by this particular mocked response. And all of those mocked responses are under another
Oh my
attribute
gosh,
called
that's
mocked
cool.
responses.
That's so cool.
Okay.
Sorry, I got excited. This is really cool.
So you can imagine like how this can be extended for any kind of behavior you want to test for your state machine in isolation. You can totally abstract away the service integrations, and you all you have to take care is how the response should look like today mock config file doesn't validate whether this is a actual response that a service would return, but the idea is to stick to as close as possible to the service response that you get from an actual service, and you can just keep adding them as mocked response. So in this case, the mock response is saying that the zeroth as a key says that anytime this state is executed for the first time, you provide this response back, you return this response back. Now with state machine, you can revisit the same state multiple times because it's not a acyclic graph. You can go back to a state, which means you can also specify the first time, second time, or the nth time when this state is revisited, what should be your response. So all of them can be provided in this setup. And that is what we have done with the retry use case, what is shown in the blog. In
Now
the retry use case. Yeah, go ahead.
in this particular configuration, you have some numbers in there 6, 7, 8, 9. Those correspond to the bullets down below.
Yes. It
Okay, good. So
explains what
because
actually they are.
that's bad JSON, Dhiraj. I'm just throwing that out there. So for those of you who are looking at it
Yes.
going, that's bad JSON, that's what that is. So
Yeah. So it just explains what actually it means here. So this can be 0, but in case actually I can jump onto the actual mock config file here since we are in the.
fun. Okay, yeah. Let's get crazy.
Okay, is this visible?
It is. Yeah, yep. Yes, sir.
Okay. So if we jump onto the retry use case where I'm saying check identity should pass, should be a success, check address should be a success, but detect sentiment service is not available. We are getting an internal service exception, but we have already set up some retries in our state machine. So it should try for X number of times, and the final or the third retry, it should give back the expected response, what you're looking for. And I can mimic that. And that is what I've done here in this use case where I'm saying for the first attempt, when you call detect sentiment, it should fail and throw internal server exception. And you do the same thing for the subsequent 2 attempts, which is 1 and 2. And for the third retry, so the first attempt is the 0th attempt. When it comes to retries, I've set up it as 3 retries, which
Okay.
means after the 0th attempt, there'll be first retry and then second retry. The first 2 retries, they fail with an internal service server exception as well. But finally, on the third retry, it should return back a valid response from detect sentiment. And you can test this scenario every time. So you can say from 0 to 2, which means for the first attempt and the 2 retries out of 3 retries, give me the exception back. But in the final retry, make sure that service mimic how the services should be working or working properly and should return back a response. And you can test this behavior by looking at the history that it tries once, twice, and it also applies the exponential backoffs and intervals if you have specified them in the state machine in the retries. You can test it accordingly.
Very cool. Now, are you gonna show us this in action?
Yes, what I'm going to do is
I'm
the
glad you
block
said
covers.
yes. That would have been awkward. No. Oh, okay.
So the block covers how you can test this using CLI, and the app, the app itself has examples how you can test this in CLI. Just to be very frugal here with our time, what I did going ahead with, I added a make file. And all you have to do for all those test cases to run, once you clone this repository, you can just run make run. Please make sure your Docker engine is running. Which make run will go and pull the latest image and spin it up for you, the step functions local. Make all will run all of your test cases, which I have mentioned here in the repository, and then make history will show you the history of each execution. But still, you can just see the history as JSON output. You won't be able to assert anything at this point to see whether your application has actually traversed through this particular states or not. So for that, what I did immediately after this blog was released, I wrote a test using JUnit and Spock, just to showcase how you can write this using JUnit or Spock. So
good job. Thank you.
Right now, the same state machine we have. Like if I go back, this is a sample app which is also available publicly under the same. So I can share the link. It should be in the same AWS Step Functions example, but I can provide you the link.
We have a question. Can we do a few questions really quick?
Yep,
so I'm
sure.
gonna go back. So let's answer. He just asked Alper codes. He's just asking questions. Do we need Docker to run the tests?
Yes, you would need Docker to run the tests.
Okay. So we're mocking some of step functions within Docker.
Yeah, there are two ways you can run using Docker. And the second way is you can get the jar file as is and just run a executable jar in your machine. And that way you get to interact with the local host and that particular port.
Okay, so let's take another question on that, and then I want to ask Alpercode's other question. Is this just Java?
Like the way I have written the tests?
Is mocking. So does this only work with? Well, I guess you could use any language, but
yeah, you can.
Okay,
you can use. In fact, we have people. We have seen enthusiasts, step function enthusiasts, who have already built this using jest tests in CDK, and they have extracted the ASL from CDK output, and then they have run jest tests on top of it. So it can be anything. The reason I chose Java in this case is because I mentioned I work with financial services customer, and I've seen most of the customers using Java for their serverless development as well, for Lambda and for any interaction that has to happen on serverless. So this becomes a pretty good input gateway for them, in the sense if they are already using Java and they want to leverage the existing test frameworks, they can just go ahead and start using this with all the local mock config present in place.
Okay. All right. So I want to go back earlier, and I know we're a little out of sequence here, but I do want to make sure we cover this question. Alpercode's asked if we have an input and output for each task and step functions, how is this different than generating, for hard coding, the input, running task, and asserting if the output matches the expectations?
I have to reread the question again. If you have input and output of each task
Sam,
and step
if you want to
function,
jump in, feel free.
I think it's important to think about what you're testing. The different types of tests we have: unit tests, integration tests, load tests, functional tests, end-to-end tests. They all kind of are targeting a particular thing about the solution you're testing, right? And in this case, we're really focused on the flow of the workflow. So step functions in the domain-specific language called the Amazon States language has all these configurations or definitions where you describe the behavior that you want, and step functions is a runtime that executes that behavior. So what you're really trying to test with a local mocking is not so much how does the Lambda service actually work, or what is your Lambda functions responses, or how does the text sentiments, CLI work or behaviors work, right? The step functions local doesn't even validate the responses that are coming back currently. So it is really not the focus to test the actual integrations with these services, as Eric was mentioning earlier. We really want to get into an AWS account as fast as possible and get that type of test in place. It's more about testing the flow. So if you have conditional logic inside of your workflow that says when the previous result is X, go left, or otherwise go right, or the retry logic, those are the types of things that you're trying to validate for a unit test. And then, as we mentioned, like after that's validated, whether it's in a local environment as part of a pipeline, you want to get that into an integration environment as quickly as possible, and then run a more full set of tests that actually integrate with these services, so that you're not relying on your mocked responses ultimately before you deploy into a production environment.
Great, yeah. Sanity check. I mean, it's really what it is. So yeah, very good. So let's see, a couple of other ones here real quick. And then Dhiraj, I want you to get back to that. But it says, can we mock steps? And Dhiraj, if you're going to kind of touch on this a little bit, we can talk about it then. But it says, can we mock steps which have maps with each map item with different mocked responses? Can we get that granular?
You can definitely mock a state which has map, and for different mocked response. Sam, have we tested this one, or we can get back to this in detail? I have not personally tested this with map, but with the times of returns that you can do with 0, 1, 2, 3, that should provide the response back when you know the number of items that are in the map and how many times each map state will be executed.
And if you want to run a test on that or something later today or this week, something like that, and we can tweet that answer out also, something like that. Alpercode's following up here. Sorry, I'm a little slow. So this is back to what you were saying, Sam. If we were testing the flow, isn't that testing the step function itself?
Yeah, so you're testing part of the step function. So we can think of step functions offering like a couple of different capabilities to us, right? So what we're not testing is the fact that step functions, that it will correctly call an AWS SDK for you, right? That's part of the services contract and it's baked into it. What we're more testing is your workflow definition. So it's not testing the service, it's testing your workflow's definition for what you want to happen in certain situations, right? For either based on your conditional logic, based on your workflow definition, or in the, we talk about all the time, right? In AWS, this failure happens, we need to plan for it, don't let it be a surprise. Well, this gives you a way to actually test failure without for example, the text sentiment service having a transient error that, returns a service exception. That's harder for you to force to produce and test. So this gives you the capability of validating, especially those failure scenarios, that your workflow will behave as you expect it to when those things happen.
Okay, great. All righty. All right, so I wanted to, we had this comment, it's kind of interesting, is what he said. He says, I believe it's more testing the flow of the state with an expected response, not the steps integration with an AWS service. That would be
Great.
A legit statement. Yeah.
Zach, very well done.
Yeah.
You're much more concise than I am.
Zach, you're hired. So speaking of which, let's take a 2-minute plug. Dhiraj, what are we hiring for?
Yeah, we have definitely requirements for having serverless folks who are interested to work with our worldwide specialist organization. And please get back to me. I can share my email address. It's mahadhir@amazon.com. And if you are interested to talk about serverless, to talk to customer about serverless, please get back to me, and we can talk more about what openings I have right now.
I just posted your email, mahadhir at amazon.com. Did I
Yes.
get it right?
Thank you.
Okay.
Thank you,
You
Eric.
are welcome. The whole world has it. I'm going to email you a lot now. So, all right. So we have some other questions coming in, but we'll come back around to it. I want you to be able to show this. Can you blow it up a little?
Yes.
Thank you.
Is it good?
Yeah. That's good. Thank you.
Okay. So we take the same state machine in the example, like we have a validation phase which is parallel, and we nothing changes in the ASL itself. So if we want to have the state machine work in an account and simultaneously test them locally, you should not be changing anything in the state machine, and that should be the default behavior. You should not be changing your source to test. So whatever you have in your ASL should definitely work as long as it's a valid state machine's domain specific language. So in this case, we have check identity, which actually looks for a function. Same with check address, which again works with another Lambda function. And this is not limited to writing a Lambda function. If you have an existing service, now think of an organization where they have already invested building an API which has functionality to check identity and check addresses. You don't want to reinvent the wheel. You can integrate very well with APIs. By if it is provided by API gateway, you can directly integrate with state machines with API gateway. So this is just for the example. It's a plain simple check address and check identity, which checks that the address has all the valid fields like street, city, state, and country. And similarly for identity, email is valid and the SSN is valid, something like that. And after that, immediately after this check is done, we grab the results from each check, and then we capture what Sam was talking about is why do we want to test this behavior of state machine, right? Now, this can be your custom validation error. Right now, I'm throwing an error if there is any failure in check identity or check address. You might be throwing some other error, or you might be having a different business exception that you want to catch in your state machine and react to that business exception. That is exactly what we are testing. So, if you have a business exception that is thrown out, how should your application behave in order to reduce the blast radius, in order to gracefully degrade and send some information back saying that there was a business exception, but we want to handle it gracefully. So that is what we are trying to test in the mock config. In this
We're
case,
testing
just an
how we
example.
handle these responses, right?
Exactly.
Yeah.
So we catch an exception. If it is a business exception, in this case, it's a custom validation error, or you just bail out saying that everything else I want to capture this as a validation exception and throw it in some other form. Then we have detect sentiment, which checks if there is any kind of comments that has come in the data. We call the comprehend API, which detects the sentiment and provides the result back. And again, I'm retrying on internal server exception. This is the example that is shown in the blog. I want to retry if there is an internal server exception, and this is a valid exception that comprehends detect sentiment API can throw. So I'm capturing that in case of an error. I want to retry it max 3 times with a backup rate of 1 and an interval of 1 second. And if everything goes fine, if there is a positive sentiment, then I go all the way to the choice block. If it is positive, then I want to add it to the follow-up. Otherwise, it's a negative sentiment. It can be neutral, but just for the sake of testing it, we decided anything other than positive is a negative sentiment. And then finally, as Sam mentioned, all of those items are sent to event bridge to the default event bus with put events. Now, how do we want to test it? You can definitely do that in the CLI, what we shown in the blog and what the application sample application shows. But if this were your Java application where you have your lambdas, where you have your lambda function written in Java, etc., how do you want to test that? So plain simple. Normally, if you have applications in Java, the the default mechanism of testing in Java will either be JUnit if you're testing it, or it'll be Spock if you are using Groovy based Java framework, which can really do some behavioral driven development. And we'll see how a Spock test would look like. I can talk like for 2 or 3 hours about Spock framework, and because I like it so much and I have used it in my past life. But just to keep it simple here, what we are testing is we spin up a container with step functions local. We create a state machine taking from the ASL file that we saw, and then we call those start execution with each of those test cases, and then whatever response we get back, we have to just assert that, yeah, this is expected, this is how it should work. Now, what I'm showing here is just the JUnit version. The Spock version is similar, but you'll see how BDD helps with when you write Spock driven tests. And one critical point here to look at is I'm not sure if anybody here has used test containers, but test containers is one of the tool that is available today where you can run any generic container and you can have your tests calling test containers and calling their API, and you can validate everything. Uh, I would highly suggest go and check out test containers, and it has different predefined containers like local stack, which is used to mimic how AWS services would work. But if you just want to use any generic container, in this case, the way we have used, you can just get generic container and define the same way you would do while running a Docker container. So you get generic container and just getting the SFN local image, running it in port 8083, binding the mount, and then providing the mock config file from my local to the container, and then going ahead with my tests. So before I execute any of my tests, I want to make sure my SDK client is ready, which is here. And then I deterministically I put a thread.slip because I realized if this wait or pause is not present, you'll see some non-deterministic behavior. I'm trying to see what would be a better way to come around this and instead of using a thread.slip. But once the client is created, you create the state machine, and this will only be done once before all the tests are run. Now you have the state machine ARN. The first thing I check in a test is whether my container is running or not. And I'm asserting on that. If this fails, obviously everything else will fail. And then test the happy path. Now, the only caveat here while testing happy path or any test case for step function is that we have to append the name of the test case to the actual ARN of the state machine. So that's what it programmatically you can do here. You got the execution response. You assert that your execution response is present. Again, you do a sleep so that the container, the Docker container actually renders all of the output in the standard out, and wait until you call the execution history. Now, once you get the execution history, you know exactly what the history will look like because this is statically typed language. Your SDK provides statically typed methods which you can use to assert on different things. Right now, I'm asserting that my last state exited event is a customer added to follow up. And as soon as I get that, I assert that the result is present. That's part of the history. Same goes with negative sentiments and retries. So in case of retry, what I'm trying to do is I'm filtering on the history and checking that my first three results in the history are internal server exception. And finally, I'm able to successfully call the comprehend detect sentiment API as it is driven by the mock config file. And you can very well assert all of those in by writing simple assert statements which are available in JUnit and Jupyter. So this makes it very easier to programmatically assert your responses that you got from your history instead of eyeballing in CLI what is the expected response. So and it brings your tests very close to your actual application where you are actually running your state machine.
Hey, Dhiraj, I'm going to interrupt you for a second.
Mhm.
We have quite a few questions coming in, but I'd like to see this run. Are you ready to run it? Okay, we're running out of time, so I just want to see if we can run it real quick. But
Yep.
not your email. Yeah, there. That's never good.
Yeah, we can definitely run it. When I run this,
Great.
it will run both Spock and JUnit.
Okay.
And the
Alrighty.
Spock test looks similar, but it has some syntactic sugars, which is provided by Groovy. You don't have to write multiple test cases. You can write one test case which takes care of all of your use cases, and you provide how should each one of them behave. So that's the
Nice.
syntactic
Okay.
sugar that provided by Spock.
Nice.
So this is a Gradle project, and I have the dependencies here. Let me blow this up a little bit. It just uses two plugins, Groovy and Java, and it uses Groovy 308, Jupyter, JUnit Jupyter engine, and anything that is provided by test container and the SDK itself. So if I run right now the test, it should show me all of the tests that are available under source test, and it should run both Groovy and Java tests. It should be able to assert on whatever conditions I have provided, and it should be checking whether one is working or not. So it's categorically checking that my happy path execution scenario works, negative sentiment, retry tests, etc. This is the Spock spec, and the next set of tests will be from the JUnit spec. Oh, now the JUnit failed. I have to find out what was the reason. But anything, the Spock specs work, and you will be able to see the standard out, because I have mentioned in the test itself with test container that any output that the Docker container provides, pipe it to your standard output, and I should see the output here, right?
So we have some approvals from the audience there, Dhiraj. This is awesome. Yeah. And I agree, Alexander. Speaking of which, let's jump back. Are you okay for me to ask you all some questions now?
Yep.
Shoot.
Okay, I kind of interrupted you. I'm going to go back real quick. Sean asked in YouTube. Let me jump back here. And I think this is just one we can answer quickly. This is for Docker run. How do we set up AWS Step Functions local credentials?
There is a flag. I can.
Okay.
It's a env file. I have to give the actual name, but it is present in the user guide. Let me find that out for you.
Okay. Yeah, we'll find that. We'll find the documentation for that, Sean, and we'll post it here as soon as he gets that.
Eric,
yeah,
that brings up a good point. We didn't cover in our blog, but this tool does support hybrid models as well. So you may choose to mock some things locally and integrate with others. So Sean, that is supported if you have the right credentials in place.
Very cool. Does it use the AWS credentials file, or do you set a separate credentials file like this?
Yeah, it's a special setup. It doesn't refer to that.
Yeah,
AWS
I sent you the link.
Oh, good.
Eric.
Okay.
Yeah, you can forward that.
All
so
right,
it's called env
this.
file. Yep.
Okay, I will post this in that. All right, so let's jump to another one. And Sean, I'm going to post that real quick here. We had another question. Hang on a second here. For local development. Okay, yeah, we're going to jump on. I think we answered that. One moment here. Okay, so here's one from Alexander. It says, how do you test a state machine running in the cloud, which calls a third-party API in one step? How to mock a third-party API?
So I can answer this one. You really have to introduce a proxy that you can control, right? So currently, Step Functions doesn't support a direct outbound HTTP request that is supported in EventBridge with something called API destinations. Definitely heard this request from customers for Step Functions. It's something we're looking into, but you can't currently do it. So therefore, you need to call a Lambda function, or in some cases, you could proxy through API gateway or something else.
There you go.
In those cases, then you are essentially mocking the endpoint that you want to test in the response. It's kind of like the service mocking, right? You can think of our services as AWS superpowers that you're integrating with versus your own superpowers. But essentially, you need to mock those responses yourself.
I have a SAM template example of, and I love the pattern of taking an API gateway and doing an HTTP Moxie or Moxie. I'm making up Moxie. I got Moxie. I'm doing an HTTP proxy in front of your third party. Because a couple things you can do there is, for instance, you can add your credential headers as needed. You can do some different things. So if you have an internal group need to make a call out, then you're basically proxying that API internally. And it's pretty. And I have some examples, and I'll post them in the serverless land patterns. But it's pretty straightforward. And then, like Sam says, you could just mock that up. So,
and I'll just point out that we'll find the link to. There's a reInvent session from this past reInvent featuring Taco Bell and a guy named Robbie Kohler walking through an example with Taco Bell and integrating with their delivery aggregates, things like Uber Eats. And they had this exact problem. How do they mock their external integrations with their partners in a way when they wanted to do load testing? How can they load test to ensure they can handle the number of orders without actually making those orders to their delivery partners? So there's some more information we can direct you to there as well.
There was a question says I need these tests. Alexander, I think put it. I actually just posted the link for the Java examples, so you can look at that. It's in there. We had a question from Alpercode. Says, how about generating the business exception payload detect sentiment will send in the event of a failure and unit testing that in the next test, asserting that it is handled gracefully. Is that doable?
Yep. So in this case, and you should, we have that example in the GitHub repository. The case where we're doing a parallel validation of the address and identity also handles a case in which there's an unexpected exception error. So we're handling both the expected business errors as well as service exceptions in the case where maybe calling the Lambda function doesn't work because of permissions or intermittent issues and doesn't work on a certain number of retries. Then there's a catch statement within the workflow definition, and we have we're actually testing that in one of the use cases in the GitHub repo. And then how that's gracefully handled is based on your workflow, what you decide to do with that exception, what's the next state that you go to. And so you can control the validation, the behavior and validation of those graceful exception handling.
Great. Okay. So another question here. What is the best? And I know we probably won't say this is the best, this is the worst, but what, I guess let me change this question to what are some example frameworks for state machine triggered from a .NET Core app? Do you have any examples, or they say, or do we have to use JUnit or Spark?
It's not Spark, it's Spock. Spark is a different framework,
yep.
But yeah. Anything that can run a container and can call AWS SDK from your test framework should work.
Okay.
So the reason I chose to use test containers is because that I have had experience using it, and with Java-based applications, the integration becomes seamless. Anywhere in my test, you will not see that I'm particularly asking the container to start or stop. That integrates with my testing framework, because that kind of integration is provided by test containers. So all I'm doing here is I'm providing a shared annotation saying that this should be available for all of my tests. Just make sure you start the container before any of the test runs. And test container will make sure and figure out this is a Spock test, I should run it before any test, or this is a JUnit test, I should run before, create the container, run the container before any of the test. So anywhere you will see I'm not specifically saying that start or stop. All I'm checking is whether the container is running or not as my first test case. So that being said, if you have a synonymous way of doing that in .NET applications, like similar to test containers, or you can directly have a client which can run Docker containers, you can put that in your test cases, and as long as you have access to the SDK and that Docker client, you should be good.
Great. So we had this. It's more of a question. It says, can we conduct Dhiraj for some more sessions in container Lambda functions? Here's the deal. If you ship me an email, I'll actually put Dhiraj in a box and ship him wherever you want him. So he comes with a pizza and a Diet Dr. Pepper, but you have to feed him after that. So no, Dhiraj did post his email. We are glad to, as much as we can. Obviously, we have our day jobs and we're doing things, but answer questions. Dhiraj, you want to put your both actually Sam and Dhiraj, if you'll put your Twitter handles, or just say them so folks have your Twitter handles to reach out and follow up on that.
I can do that. I'm giving it right now.
Okay. All righty. So
mine's
we'll do
just
that.
my name, at Sam Dengler.
Okay. At Sam Dengler. That's nice. I didn't. Mine was taken. Darn it. Eric Johnson's so uncommon. So, all right. So I just posted here's Dhiraj's, and I'll put at Sam Dengler. Okay. So I just posted both of those. That's probably, I don't know about y'all. That for me is probably the best way to get a hold of me. And you can reach out. With that, we are right at time. Fantastic demonstration. I know we probably didn't cover. We could go for hours on this, and I get that. But I encourage you to read the blog, follow up. I think we've posted all the links here that you can follow. Here's I have actually one more here. We're going to post some frameworks for you. This is the Spock framework link, and I'm going to post the JUnit link as well. I encourage you to check them out. Reach out to us if you have questions. Dhiraj, you have anything else you want to throw out real quick?
I did not see the Spock framework link or other link come in the comments, but
just added it.
Okay. Yeah.
Pedantic much? Just kidding.
No. In general, you're not limited to just Java or .NET, or Node.js frameworks for testing. Whichever works for you, please use that.
Okay.
And make sure the important part is to assert your tests programmatically instead of spending time to figure out and eyeballing and understanding whether you got the response or you traverse the proper state machines or states or not. As long as you can programmatically do that and use that as part of your software release cycle, then that's the best place to go. So try to use this in your existing testing frameworks and see how you can incorporate that in your CI/CD cycles.
Awesome. Sam, you have anything you want to throw out?
I'll just say that the Step Functions team is very excited that customers are interested in using this, and they really want to hear your feedback. So reach out to Dhiraj or I or Eric and let us know what you like, what you don't like, where you would like to see us invest next to help this integrate with your developer workflow and experience. You have a lot of active engineers and service folks that are acutely interested in your thoughts. So don't be shy. Let us know how we can, build on top of this for you.
When you notify us this stuff, we really do sit down with the teams and we tell them, hey, this is working, this isn't working. Hey, whatever. Next week, we are at time. So I'm going to tell you next week, you can see from Julian's post up here, is Amazon AppFlow Custom Connector SDK. If you're moving a lot of data around, if you have siloed data in different places and you need to do reporting on that data collectively, you got to be checking out AppFlow, specifically with the Custom Connector SDK. And how do you pull data and do reports? AppFlow is a low code to no code somewhere there where you just configure the connection. You can pull it in from lots of different connectors. So encourage you to come next week. Check that out. With that, Sam, Dhiraj, thank you so much. Really enjoyed doing the show with y'all. And we're out of here. See y'all later. Thanks, Julian, for the reminder.
Thank you, Rick.
All right. We're ending. It doesn't end right away.